Okay, so this problem reads, a basketball player is running 5 meters per second directly toward the basket when he jumps into the air to dunk the ball. He maintains his horizontal velocity during this time while he's running. All right, so what vertical velocity does he need to rise the 0.75 meters above the floor to dunk that ball? And how far from the basket, measured horizontally, did he take that jump to reach his maximum height just at the same time as he hits the basket? Okay, so here's a problem in two-dimensional motion. He's flying both forward and up to dunk that ball. So with kinematics, we want to start with identifying the object of interest. So what is our object? And in this case, it's the ball and the player together, right? He's dunking the ball, so he always maintains contact with that ball versus throwing it to the basket. What defines when we start caring about the motion, and what defines when we stop caring about the motion? What is our time of interest? Well, we start caring when he takes off the ground. So when he lifts off the ground to jump towards that basket. And we stop caring when he dunks the ball. Now, there's some key information in there. This, remember, is at his maximum height. Okay, so it says that he dunks the ball at the maximum height, and that's going to be important for us. Okay, so let's draw a picture. Here we have our player, and there's our basket. We don't exactly know where the basket is. We do know that the player starts at a horizontal position. We'll define that as the origin, where he's located. And, well, it might make more sense to put the horizontal on the bottom. Ooh, that blue is messy. Okay, so this horizontal position of the origin, the horizontal origin we'll say is when he takes off. And let's say that the vertical origin is the ground. We know that the basket is the basket. He has to jump 0.075 meters for his hands to dunk in that basket. Okay, I want to keep that in mind. So we've set our picture, we've defined our origins. Let's make our horizontal and vertical list of variables. So here's our horizontal and here's our vertical. So we have x initial horizontal, x final horizontal, v initial horizontal, v final horizontal, acceleration horizontal, and our time. So there's all our horizontal players and our vertical players. So x initial vertical, x final vertical, v initial vertical, v final vertical, acceleration vertical, and our time vertical. Okay, so what do we know and what is implied? Well, we know that our initial position is where we've defined the origin. So he starts at 0 meters. We aren't sure exactly where the basketball basket is, so we don't know his final position. We're told in the problem that he's running at 5 meters per second and he maintains that position when he dunks the ball. So our horizontal initial velocity is 5 meters per second. And since we're interested in when he lifts off in the air, we know that there's no acceleration horizontally. He's in free fall. So our final velocity horizontal also has to be 5 meters per second. So in free fall, only acceleration is vertical. So the acceleration horizontally is 0. And we don't know how long he's in the air. It's not provided in the problem. Well, what about vertically? Well, we've defined the origin at the ground, so we know that he starts at the origin 0 meters. The problem tells us he has to jump 0.75 meters to reach the basket at his maximum height. So his final position is going to be 0.75 meters. We're interested in knowing how fast he has to jump off that ground vertically in order to reach that basket to dunk. So, whoops, that was a question mark. So we don't know his initial velocity vertically, but we're told he reaches a maximum. And we know in two-dimensional motion, projectile motion, that maximum has a final velocity of 0 meters per second. So it's not given as 0, but because it's a maximum, we know that it reaches that's that turning point when we're moving up and down. We're in a state of free fall, so the acceleration is negative 9.8 meters per second squared. And again, we don't know the time. So this problem had us interested in two different items. One, how far away from the basket we are. So where does he end up horizontally to know how far away he started from? And the second thing we were interested in is how fast does he have to jump vertically in order to make that dunk at its maximum? So those are our two variables of interest. So let's start with one of them. Let's start with our final position. That was the first one asked for. If we're interested in final position, we got a couple equations with position information in them. Let's look at our, what affectionately is my favorite equation. It's usually very effective. And when we're dealing with a case of zero acceleration, this term always goes to zero, and we're often left with the equation that's going to be most valuable. So, x final, we don't know. We're going to keep it the variable that it is in the list. X initial is 0, plus our initial velocity is 5. I don't know the time. So if I simplify this, the final position, which is how far away I am from the basket, is 5t. So I need time. Well, when I need time, it's often the case that I look to the other variable, the other list, the other dimension, because time is the same in both of these. So let's go ahead and look at the other dimension. Well, I have initial and final position, I have final velocity, and I have acceleration. We know that our final velocity is equal to our initial velocity plus my acceleration times time. Let's see if that helps us out. Well, my final velocity is 0, and that's going to equal, oh, that's a question mark, my v initial vertical plus negative 9.8 times t. Now, I went to this equation to get t, but I'm still not able to get it. If I look at the other equations, they also either require initial velocity or they acquire initial velocity. So both other equations also require the initial velocity. So I need initial velocity in the vertical. Well, that's one I want anyway. So let's go after that initial velocity in the vertical direction. Now I don't have time, so I might not want to choose one that has the time in it because I don't know the time. But we do know that other equation, v final squared is equal to our initial velocity squared plus 2a times my displacement. 2 times the acceleration times my displacement. Well, v final is 0, so I have 0 squared. I don't know v initial squared plus 2 times negative 9.8 times x final, 0.75 minus 0. All right, so I can solve for v final squared. I get minus v initial vertical squared is equal to 2 times negative 9.8 times 0.75, which is negative 14.7. So my v initial in the vertical direction, if I take the negatives, cancel each other out, take the square root, I get 3.83 meters per second. Well, hey, that was part B. I need to know the initial velocity in the vertical direction. And now I can use that to get my time. So I have 0 is equal to 3.83 minus 9.8 t. And if I bring that 9.8 t and solve for t, I get time is equal to 0.39 seconds. And then I can plug that one back up here in my final position. And I find that my final position is 5 times 3.9, oops, not 3.9, that would be a long jump. Let's erase that. 5 times a 0.39. My final position is 1.95 meters. So for part A, they started 1.95 meters away from the basket, and if he maintained his horizontal velocity when he jumped, he would have had to jump vertically 3.83 meters per second. Okay, so identifying what we're interested in, what we're caring about, our initial and final times, what do we care about in the motion, making sure that we're identifying both origins, a horizontal origin and a vertical origin, because this is two-dimensional projectile motion in case of free fall. Identifying what we are aware of, recognizing there's no acceleration in the horizontal direction. We do have that gravity acceleration in the vertical direction. And then going after what we want. We wanted x final horizontal, and when I go after x final horizontal, I recognize I need time. So we go after time in the vertical direction. Oh, well, that told me I needed the initial vertical velocity. So I go after that initial vertical velocity, which was one of the things I was interested in, plug that back in to find my time, which I can then go back and find my final position. All right, good job.